Hello student, in previous class I discussed about the third law, that is your law of multiple perversion, and I have also given some problem, and these are the problems I have already solved. Next I have discussed the another law, that is your law of reciprocal proportion. This is law of reciprocal proportion. I have given two example. Example 1, example 2, these are the few examples. Next, I have also completed few problems. This is problem number 1. Next, this is problem number 2. In the previous class, I am unable to explain clearly about the problem number 2. In this class, again, I want to again revise the problem number 2. Look at that. I want to try again to understand you. So that the following result illustrate the law of reciprocal proportion. Here, 0.92 gram of magnesium produce 1.54 gram of magnesium oxide. This is one experiment. And the second is 0.41 gram of magnesium liberate 0.0342 gram of hydrogen from an acid. Next, third is 1.25 gram of water result from the union of 1.11 gram of oxygen. Three points are given. One is if I want to draw the triangle, then I will draw like this. This is the triangle which clearly explain. In the point, if you want to see, look at that here. 0.9 gram of magnesium produce 1.54 gram of magnesium oxide. That means here magnesium react with oxygen, produce magnesium oxide. If you think about the second, here 0.41 gram of magnesium liberate 0.0342 gram of hydrogen from an acid. That means here obviously here you can think about magnesium plus that is your hydrogen. Next, 1.25 gram of water result from the union of 1.11 gram of oxygen. Your water present. Look at that, three compounds are present. Among the three compounds, two compounds having the that is your same mass. If you think about your magnesium hydrate, look at that, here magnesium is given, here magnesium is given, here hydrogen is given, here hydrogen is given. Here oxygen is given, here oxygen is given. Any two compound having at least one of the element is same. So for proving the law of reciprocal proportion, it is highly necessary to solve as per the definition. If I will think about the point I can write here mass of magnesium oxide, that is your 1.54. This is the mass of magnesium oxide. Mass of magnesium, that is your 0.92 gram. Mass of oxygen in MgO is your what? Mass of magnesium oxide minus mass of magnesium. Mass of magnesium oxide means 1.54. Mass of magnesium means 0.92. That is your 0.92. If you will subtract this, that means 1.54 minus 0.92, then we will get 0.62 gram. This is a what? Mass of oxygen. This is mass of oxygen. Clear? So here I can write 0.92 gram of magnesium combined with oxygen means 0.62 gram. That means 0.92 gram of magnesium need 0.62 gram of oxygen. This is the all about eye experiment. Next, go to the double eye. Here 0.41 gram of magnesium liberated hydrogen is your 0.0342 gram. Next, here 0.92 gram of magnesium liberated hydrogen is your how much? 0.034 2 divided by 0.41 into 0.92. If you solve this, then you will get the value like this, 0.07. This is the amount of hydrogen which is liberated by using 0.92 gram magnesium. Look at that, here 0.92 gram of magnesium, here also 0.92 gram magnesium. If you will think about the double eye experiment, look at that. Here 0.41 gram of magnesium is liberated. You will also solve the problem by comparing to one part, 100 part like this. That means I am talking about like this. Suppose if you think about the experiment 1, here you can say that in experiment I, here you can say that 0.92 gram of magnesium. Need oxygen is your how much? Oxygen is your 0.62. Suppose a student wants to take 1 gram, 1 milligram. That means here you can take oxygen is your how much? 0.62 divided by 0.92. In the experiment double I, it is highly necessary to compare the magnesium with oxygen like this. That means for 1 gram magnesium, what amount of oxygen is needed. Our target to maintain a same value. That means here magnesium must be same in both the experiment. If someone wants to take 0.92 gram and 0.92 gram of magnesium, then in the double eye experiment it is highly necessary to maintain 0.92 gram. Suppose a student take experiment I and compare with 1 gram of magnesium. Then in the double eye experiment it is highly necessary to compare the magnesium with hydrogen by taking 1 gram of magnesium. Suppose a student now will compare, will find 100 gram of magnesium. Then in the double eye experiment, it is highly necessary to maintain 100 gram of magnesium, and it must be related to the hydrogen. What amount of hydrogen? That is your target. That means target is to maintain the equal. If you think about the magnesium, if you want to make the magnesium amount is equal, it is possible. You may be compare with the 1 gram, 100 gram, or the given data. Here 0.92 gram of magnesium is the given data in the question. So I do not proceed to 1 gram, 100 gram. Just I kept 0.92 gram magnesium. So in the double eye experiment, it is highly necessary to bring 0.92 gram magnesium and find what amount of hydrogen will liberate. That is our target. At least one element must be same in both the experiments. Whether you take 1 gram or 100 gram or 50 gram, is your choice. The weight of magnesium must be same in experiment I and in double experiment double I. Here I have taken 0.92 gram of magnesium in experiment I. So I have here also uh, found 0.92 gram of magnesium. Now, if I will maintain magnesium weight is a constant, that is the same in both the case, then now next step is find out the ratio of oxygen and hydrogen. Oxygen from that is your from experiment I, hydrogen from experiment double I. So here I can say that the ratio of oxygen and hydrogen is your how much? This is the amount of oxygen, that is your 0.62. 0.077 gram. This is related to the double eye experiment. So here I can write here the ratio of oxygen and hydrogen is your how much? 0.62 ratio 0.077. If you want to solve this, then you will get 8 is to 1. That means the ratio of oxygen and hydrogen is equal to 8 is to 1. Now find the oxygen and hydrogen ratio in water. Look at that. Weight of water in question is your 1.25 gram. Weight of oxygen in also in question is your 1.11 gram. Now you will find the weight of hydrogen by subtracting the weight of oxygen from the weight of water. So here I can write weight of hydrogen is equal to 1.25 minus 1.11, which is equal to 0.14 gram. Here the oxygen weight is your 1.11. Here the weight of hydrogen is 0.14 gram. Now find the ratio of oxygen and hydrogen. Here we will write that is your how much? 1 point, that is you will write 1.11, that is your 1.11 divided by 0.14. If you want to solve this, then you will get 8 is to 1. Look at that. Here 8 is to 1 is already I determined. Here also 8 is to 1. Just I I found. So here I can write here the ratio of oxygen and hydrogen combining with the same mass of magnesium. Same mass of magnesium means I have taken here 0.92. You will also find for 1 gram, for 100 gram, for 10 gram, is your choice. But it is highly necessary to maintain the same value. If you want to find 10 gram in experiment to I, then it is in compulsory to find the 10 gram of magnesium in double I experiment. So here I can write the ratio of oxygen to hydrogen combined with the same mass of magnesium is your 8 is to 1, which is same as the ratio of oxygen to hydrogen in water. That is your also 8 is to 1. Since the ratio is same in water and also in another, that is your magnesium oxide and magnesium hydride, so the law is verified. Look at that. Here 8 is to 1. Here also 8 is to 1. So the law of that is your reciprocal proportion is satisfied. So here I can write the here the ratio of oxygen to hydrogen combining with the same mass of magnesium is 8 is to 1, which is the same oxygen to hydrogen in water. So the law of reciprocal proportion is verified. Reciprocal proportion is verified. Clear? Next, move to the next problem. This was also doubt. Now move to the problem number 3. Aluminium combines with the oxygen in the ratio 3 is to 2 by mass. Aluminium also combine with the chlorine in a 12 is to 1 ratio by mass. According to the law of reciprocal proportion, find the ratio of by mass in which chlorine and oxygen will combine. Look at the triangle. Here I will draw a triangle. If you will draw the triangle, then it is very easy to understand, and clearly you will write. Aluminum combined with oxygen. That means here Al2O3 is given. An oxide of aluminum is given. Aluminum also combined with chlorine. That means suppose someone wants to take here AlCl3. You can take AlCl3 by mass. According to the law of reciprocal proportion, find the ratio by mass in which chlorine and oxygen will combine. That means think about the chlorine oxygen compound. What compound? Yeah, in the question it is not given, but only given is your chlorine oxygen compound. This is your chlorine and oxygen compound. Look at that. Our target to find the ratio of chlorine and oxygen. Clear? If you think about the solution of problem number 3, look at that. Here mass ratio of aluminum and chlorine is your how much? 12 is to 1. That I have written. Mass ratio of aluminum and oxygen is your what? 3 is to 2. That is I have written 3 is to 2. To find the mass ratio of chlorine and oxygen, if you want to find out the mass ratio of chlorine and oxygen here, then it is highly necessary to maintain the mass of aluminum is same. That means the mass of aluminum must be same in both cases. Here aluminum, here also aluminum is present, but they are not same. Our target to maintain same. As a result, look at that here 12 is to 1 is given, first case. In the second 3 is to 2. How the aluminum part will be same? If you multiply 4 with this ratio, then no doubt if you multiply 2 into 4, that is your 8. The ratio of oxygen will increase, but weight of the oxygen will increase, but the magnesium will same with the case number 1. That means if I want to multiply it with the 4, then here I can write the modified mass ratio of aluminum on the oxygen. That means this ratio now is changed to this ratio. So here I can multiply it with the 4 into 3 is to 2. Here I can write 12 is to 8. Look at that. In the first case, the ratio of aluminum and chlorine is your 12 is to 1. But in the second case, now it is changed and is your 12 is to 8. Now look at that. Here now magnesium, here aluminum is 12, here aluminum is 12. Now the aluminum is constant. So I can take the ratio of chlorine and oxygen now. So here I can say that the mass ratio of chlorine comes from mass ratio of aluminum and chlorine, and oxygen comes from mass ratio of aluminum and oxygen. Simply I can say that the mass ratio of chlorine and oxygen is your how much? 1 is to 8. Here 1, look at that, here 1 represents to chlorine, 12 represents to aluminum. Here 2 sorry, here 8 represents to oxygen, 12 represents to aluminum. So oxygen means 8, I have written here. I have taken the oxygen in the second part. Here I have taken chlorine is the first part. So here the ratio must be what? Chlorine is to oxygen. Chlorine means how much? Chlorine means here I can write 1, and oxygen means I can write here 12. So the ratio is your 1 is to 8. So here I can say that the mass ratio of chlorine and oxygen is your 1 is to 8. Since this problem, the data are obey the law of reciprocal proportion. So here I can say that according to the law of reciprocal proportion, for the same mass of aluminum, the mass ratio of chlorine that comes from mass ratio of aluminum and chlorine, and oxygen that comes from mass ratio of aluminum and oxygen is equal to the ratio of chlorine and oxygen in which they combine. Now here I can say that the ratio of chlorine and oxygen is your how much? That is your 1 is to 8. That means here the chlorine oxygen compound must maintain the chlorine oxygen ratio is your 1 is to 8. Here if you think about the chlorine and think about the oxygen, here also chlorine oxygen ratio in these two compound is your 1 is to 8. Clear. So our target to find out the mass ratio, find out the ratio by mass in which chlorine and oxygen combine. So the answer is your what? The ratio by mass in which chlorine and oxygen combine will equal to how much? 1 is to 8. That is your 1 is to 8. Now move to the problem number 4. Problem number 4 is just same with the problem number 3. Here calcium, sulfur and oxygen is given, but in problem number 3, aluminum, what are the elements given? Aluminium, another is chlorine, another is your oxygen. Now draw the triangle. If you want to draw the triangle, this is the triangle. Calcium, here I can write calcium combined with sulfur means calcium sulfide. CS calcium combined with sulfur in the ratio 5 is to 4 by mass. Calcium also combined with oxygen in the ratio 5 is to 2. Calcium oxide, this is your calcium oxide. Here calcium sulfur ratio is your 5 is to 4. In calcium oxide, the calcium and oxygen ratio is your also 5.2. Look at the problem. You will you can easily understood. Here calcium sulfur ratio is your 5:4. Here calcium and oxygen ratio is your 5:2. Now think about the other element. Look at that. According to law of reciprocal proportion, find the ratio of mass in which sulfur and oxygen will combine. That means here the compound must be sulfur oxygen compound, and our target to find out the ratio of sulfur and oxygen. This is our target. Move to the solution. Mass ratio of calcium and sulfur. The calcium is to sulfur is your 5.4. As per the question. As per the question, here also we can write mass ratio of calcium and oxygen is your 5:2. Look at that. Here calcium part. Here calcium is 5. Here also calcium is 5. That means we can say think that here calcium is now constant. So our target to find out the mass ratio of oxygen and sulfur. Sorry, you can find the ratio of sulfur sulfur is to oxygen. This is your target. Find the ratio of sulfur is to oxygen. So to find the mass ratio of sulfur and oxygen, the mass of calcium must be same in both cases. Here the mass of calcium is the same. So therefore, we can write the mass ratio of sulfur that comes from mass ratio of calcium and sulfur, and oxygen that comes from mass ratio of calcium and oxygen, that must be 4:2. Here 4 represent to what? Sulfur, 2 represent to oxygen. So the ratio is your what? 4:2. According to the law of reciprocal proportion, for the same mass of calcium, the mass ratio of sulfur that belongs to mass ratio of calcium and sulfur, and oxygen that belongs to mass ratio of calcium and oxygen is equal to the mass ratio of sulfur and oxygen in which they combine. Therefore, here I can write the ratio of sulfur and oxygen is equal to how much? 4:2. Sulfur comes deals with the sulfur. Sorry, 4 deals with the sulfur. 2 deals with the oxygen. If you simplify this 4 by 2, that is your you can find 2 by 1. So here I can write 2:1. So here the ratio is your 2:1. So our target was what? According to the law of reciprocal proportion, find the ratio by mass in which sulfur and oxygen combine. So here I can write the ratio by mass in which sulfur and oxygen combine is your 2:1. This is the answer. This is all about the law of reciprocal proportion. Now I want to move the last law, that is your law of gaseous volume. This is your last law, law of gaseous volume. Law that is also called law of combining volume. This is also related to law of Gay-Lussac law. That means already I discussed. That is your Gay-Lussac law. Now I want to again repeat here. Under similar condition of temperature and pressure, whenever gas react together, the volume of reacting gases as well as gaseous product bear a simple whole number ratio to one another. Now take an example. I have taken a reaction with a hydrogen and chlorine, and they form the hydrogen chloride. So here I can write H2 plus Cl2 gives you 2HCl. Actually, the reactant is your what? Hydrogen and chlorine. The product is your HCl. If you balance the equation, you can say that H2 plus Cl2 gives 2HCl. Now apply the concept. That means you can also find this concept also in volume relation. That means you can find also in the stoichiometry concept. Look at that, here the coefficient is 1, nothing means 1. So here I have written 1 volume. Here also the coefficient of chlorine is not given, nothing. That means you think about your 1 is present. So here I can write 1 volume. Here 2 is present, so here I have written 2 volume. As per the law, it is seen that if you find the ratio of the reactants, here the reactant is your hydrogen and chlorine. That means the ratio of volume of reactant means ratio of hydrogen and chlorine. That means that is your 1:1. Next, if you want to find the ratio of the reactant and product, here the reactant and the product are means two reactant, that is your hydrogen and chlorine, product is your HCl. So here I can write H2 ratio Cl2 H2 ratio HCl. So here I can write 1:1:2. If you find the ratio of product, here only one product is given, so it is impossible to find the ratio of the product. Look at that. This is the ratio H2 ratio, the H2 Cl2 means the ratio of the reactants. Here the ratio of the reactant is 1:1. 1:1 is a simple whole number ratio. Similarly, the ratio of reactant and product maintain the ratio 1:1:2. This is also a whole number ratio. So here I can say that the ratio of volume of the reactant is a simple whole number ratio. The ratio of volume of the reactant and product is also a simple number ratio. So here I can write all the ratio are simple whole number ratio. Hence the law of gaseous volume is verified. As per the law, the ratio of the reactants by volume must be a simple whole number, and the ratio of the volume of the reactant product must be also a simple whole number. Remember, it is highly necessary if the temperature and pressure have the similar condition. When gases are present and the gases must have same temperature and pressure like other gas, then this concept will applicable. Now move to the problem number 1. Illustrate the law of gaseous volume. That is a law of combining volume from the following data. 20 ml of methane react with completely with 40 ml of oxygen to produce 20 ml of carbon dioxide and 40 ml of water. And all the volume are measured at the same temperature and pressure. That means the temperature and pressure, what may be for CH4, that must be also for oxygen, also for carbon dioxide, also for water. That means the temperature and pressure for all the gas must be same. Now again read the question. 20 ml of methane react with complete with 40 ml of oxygen to produce 20 ml of carbon dioxide and 40 ml of water. That means here the reactant is your methane, another is your oxygen, and the product here is carbon dioxide, another is your water vapor. So I can write CH4 plus O2 gives CO2 plus H2O. This reaction is already no. Here this reaction is not in balanced form. Here two oxygen is present. Here zero oxygen. Sorry, one oxygen is present. That means here multiplied with the. How can I solve this? One carbon. Here one carbon. Four hydrogen. Here two hydrogen. Here multiplied with the two. Here multiplied with the two. That means here you can write C4, CH4 plus 2O2 gives is CO2 plus 2H2O. Again check. Here one carbon, here one carbon, here four hydrogen, here four hydrogen, here four oxygen, here also four oxygen, here two oxygen, here two oxygen, four oxygen. Look at that. If you want to apply the, this is the equation. This is the balanced chemical equation. If you think about the volume of each gas, as per the question, I can write here 20 ml of CH4. Next, I can write 40 ml of oxygen. Here, I can write 20 ml of carbon dioxide, 40 ml of water. These are data are given in the questions. Now, apply the law of gaseous volume. Our target to verify whether these data obey law of gaseous volume or not. Look at that. Find the ratio volume of the reactants. Here the reactant is your methane CH4, another is your oxygen. The volume of methane is your 20. The volume of oxygen is your 40. So here I can write the ratio of the volume of the reactant, that is your CH4 ratio is to O2 is your 20 is to 4. Sorry, 20 is to 40. Now you will simplify and you will get 1 is to 2. Similarly, the ratio of the volume of the product, here more than two products are given. Sorry, here two products are given. So you can find the ratio of the volume of the product. So here I can write the ratio of the volume of the product, that is your CO2, and water is your how much? Carbon dioxide is your 20 ml. Water is your 40. So here I can write 20 is to 40. If you solve, then it will get 1 is to 2. The ratio of the volume of the reactant products. If you take both reactant and product, then you will find the ratio like this. 20 is to 40 is to 20 is to 40. That means 1 is to 2 is to 1 is to 2. This is the ratio. Look at that. The volume of the reacting gases as well the gaseous product. This is a simple whole number. This is also simple whole number. This is also simple whole number. So here I can write the volume of the reacting gases as well the gaseous product bear a simple whole number ratio to one another. You may think about CH4 O2, CO2 H2O, or any gas you can use. Now here you can say that hence look at that, since all the ratio are simple whole number ratio, so the law of gaseous volume, that is the law of combining volume, is verified. Now move to the problem number 2. Again another problem is given. Hydrogen and oxygen combine to form water vapor according to the reaction. Look at the reaction. 2H2 plus O2 gives 2H2O. How much oxygen is required to completely how much oxygen is required to react completely with the 150 ml of hydrogen at the same temperature and pressure? Here the condition is again same. Look at that. Our target to find out how much oxygen react with the 150 ml of hydrogen. Here the already, yeah, since here the same temperature and pressure is given, so this data already obey the law of gaseous volume. So here I can write in solution I can write given volume of hydrogen is your 150 ml. Required equation is your 2H2 plus O2 gives 2H2. By applying the gaseous volume, you can write ratio of the reactant. You can write also ratio of the product, ratio of the reactant and product. Here the reactant is your hydrogen and oxygen. So here you can apply by applying the law of gaseous volume. I can write H2 O2 ratio is your 2 is to 1. That means here I can say that 2 volume of hydrogen require 1 volume of oxygen. 2 volume of hydrogen means here what? 150 ml of hydrogen required. So look at that. If you take 2 volume of hydrogen, then half volume of oxygen is used. That means 1 volume of oxygen is used. If you similarly, if you take 150 ml of hydrogen, then obviously you take a half of hydrogen. That means 150 by 2, that is just 75 ml. Again, I want to repeat: 2 volume of hydrogen require 1 volume of oxygen. That means here if you take 2, here half. That means 2 by 2, that is your 1. If you take here 4, here 2. If you take here 100, here 50. If you take here 150, then you will get 75. So the answer is your 75 ml. So here I can say that 75 ml of oxygen is required to react completely with the 150 ml of hydrogen at the same temperature and pressure. It can be solved by using the law of gaseous volume. Next, move to the problem number 3. Nitrogen and hydrogen react to form ammonia according to the reaction. N2 plus 3H2 gives it 2NH3. How much hydrogen is required to react complete with the 80 ml of nitrogen at the same temperature and pressure? Given volume of nitrogen is your 80 ml, required equation is your what? N2 plus 3H2 gives 2NH3. By now apply the law of gaseous volume. If you want to find the ratio of N2 and H2, and it must be 1:3, because our target to find out the hydrogen, and hydrogen is related to your nitrogen. So here 80 ml of nitrogen is given and your target to find out the hydrogen. That means you make a relationship between hydrogen and nitrogen. So by applying the law of gaseous volume, I can write your N2 ratio H2, and it is equal to 1:3. That means here I can write 1 volume of nitrogen required 3 volume of hydrogen. That means 3 times. If you take 1 volume of nitrogen, then you think about 3 volume of hydrogen 3 times. If you think about 2 volume of nitrogen, then you will find 2 into 3, that is your 6 volume. If you think of 5 volume, then you will think about what? 5 into 10 nitrogen, then you will think about 10 into 3. If you think about 80, then you will think about 80 into 3. So here I can say, right, 80 ml of nitrogen require hydrogen is equal to 80 into 3, that is your 240 ml. So how much hydrogen is required? You can write the answer 240 ml. 240 ml of hydrogen is required to react completely with with what? 80 ml. 80 ml of nitrogen. You can think about 80 ml of nitrogen. This is your answer. Next, move to the problem number 4. Here, carbon monoxide bonds in oxygen according to the reaction. 2CO gas plus O2 gas gives 2CO2 gas. It is a balanced chemical equation. How much oxygen is required to burn 120 ml of carbon monoxide completely at the same temperature and pressure? That means you need a relation, that is your oxygen. You need a relationship between oxygen and carbon monoxide. Now look at the solution given. Volume of carbon monoxide is your 120 ml. Required equation is your 2 CO2 gas plus O2 gas give 2 CO2 gas. But if you apply the law of gaseous volume, here you can say that carbon monoxide ratio between carbon monoxide and oxygen is your how much? 2:1. Look at that here. Carbon the coefficient of with carbon monoxide is your 2. The coefficient with oxygen is your nothing means 1. So the ratio of carbon monoxide and oxygen is your 2:1. From the ratio here I can say that 2 volume of carbon monoxide required 1 volume of oxygen. If the thing about the 4 volume 4 volume of carbon monoxide, that means 2 volume oxygen. If you think about 8 volume carbon monoxide, then take half, that is your 4 volume of oxygen. If you think about 50 volume of carbon monoxide, then you think about 25 volume of O2. If you think about 120 ml 120 ml of carbon monoxide, then obviously you take half, that means 60 ml of oxygen. So here I have written 120 ml of carbon monoxide requires oxygen is your 120 by 2, that is your 60 ml. So what will be the answer? How much oxygen is required to burn 120 ml of carbon monoxide completely at the same temperature and pressure? Then you can write 60 ml of oxygen is required to burn 120 ml of carbon monoxide completely at the same temperature and pressure. Clear? This is the answer. That is your 60 ml is the answer. Finally, I complete the chapter basic concept of chemistry. Thank you all for watching the videos related to the chapter basic concept of chemistry. In the next class, I will start a new chapter. The chapter name is your what? The structure of atom. In the next upcoming class, I will start about the structure of atom. This is a new chapter. I completed the uh, chapter that is your basic concept of chemistry. Already I have done 24 video. Uh, Now in the next class I will start another chapter that is your structure of atom. Again, thank you very much for watching the video. Have a nice day.